This probability statistic covers Chapter 1 with 9 lessons. Focus on exploring data. For Chapter 2, random variables and probability distributions. For Chapter 3, focus on sampling. Chapter 4, on estimation of parameters. Chapter 5, test of hypothesis. And number 6, correlation and regression analysis. So, in decision making, we use statistics although some of us may not be aware of it. In this lesson, we make the student realize that to decide logically, they need to use statistics. An inquiry could be answered for a problem could be solved through the use of statistics. In fact, without knowing it, we use statistics in our daily activities. At the end of the lesson, the learner should be able to identify questions that could be answered using a statistical process and describe the activities involved in a statistical process. So this will be the lesson outline. Statistics as a tool in decision making and statistical process in solving problem. Okay, before we may proceed, I just want to ask question. So, what is in your mind at the moment? Okay, I will group you into two. Okay, for group 1 is for example, UMS, ABM, and other course. And the group 2 is for TechBook, HE, and for ICT. For the group 1, this will be the sample questions. Number 1, how old is our teacher? Number 2, is the vehicle of the mayor of our city, town, municipality bigger than the vehicle used by the President of the Philippines? How many days are there in December? Does the principal of the school has a postgraduate degree? How much does the barangay captain receive as allowance? And the last question for group 1, what is the weight of my smallest classmate? For TechBook group 2, this will be the questions. How old are the people residing in our town? Do dogs eat more than cats? Does it rain more in our country than in Thailand? Do math teachers earn more than science teachers? How many books do my classmates usually bring to school? What is the proportion of Filipino children aged 0 to 5 years who are underweight or overweight for that age? The first group of questions could be answered by a piece of information which is considered always true. There is a correct answer which is based on a fact and you don't need to process of inquiry to answer such kind of question. So, for example, there is one and only one correct answer to the first question in group 1. And that is your age as your last birthday or the number of years since your birth year. On the other hand, in the second group of questions, one needs observation or data to be able to respond to the question. In some questions, you need to get the observation or responses of all those concerned to be able to answer the questions. On the first question, the second group, you need to ask all the people in the locality about their age. And among the values you obtain, you get a representative value. And to answer the second question in the second group, you need to get the amount of food that all dogs and cats eat to respond to the questions. However, we know that it is not feasible to do so. Thus, what you can do is get a representative group of dogs and another representative group for the cats. Then we measure the amount of food each group of animal eats. From these two sets of values, we could then infer where dogs do eat more than cats. So, as you can see in the second group of questions, you need more information or data to be able to answer the questions. Either you need to get observation from all of these concerned or you get representative groups from which you gather your data. But in both cases, you need data to be able to respond to the question. Using data to find an answer or a solution to a problem or an inquiry is actually using the statistical process or doing it with statistics. Now, so let us formalize what we discussed and know more about statistics and how we use it in decision making. Again, statistics, it is defined as a science that studies data to be able to make a decision. Hence, it is a tool in decision-making process. Mention that statistics as a science involves the methods of collecting, processing, summarizing, and analyzing data in order to provide answers or solutions to an inquiry. One also needs to interpret and communicate the results of the methods identified above to support a decision that one makes when faced with a problem or an inquiry. I will give you a trivia. Okay? The word statistics actually comes from the word state because governments have been involved in the statistical activities, especially the conduct of censuses, either for military or taxation purposes. The need for and conduct of censuses are recorded in the pages of holy text. Actually, in the Christian Bible, particularly the book of Numbers, God is reported to have instructed Moses to carry out a census. Another census mentioned in the Bible is the census ordered by Caesar Augustus throughout the entire Roman Empire before the birth of Christ. So, with this uncovering patterns in data involves not just science, but it is also an art, and this is why some people may think stat is X and may view any statistical procedures in results with much skepticism. So, make note to student that, of course, the statistics enable us to characterize person, objects, situation, and phenomena. We explain relationship among variables. We formulate objective assessment in companions. And more importantly, we make evidence-based decisions and predictions. And to use statistics in decision making, there is a statistical processes to follow, which is to be discussed later. Now, statistical process in solving a problem. So, we may go back to the one question identified in the second group and we use it for the discussion of the components of statistical process. Of course, let me discuss how we could answer the question, do dogs eat more than cats? As I mentioned earlier, no, this question requires you to gather data to generate statistics which will serve as basis in answering the query. There should be plan or a design on how to collect the data so that the information we get from it is enough or sufficient for us to minimize any bias in responding to the query. In relation to the query, we said earlier that we cannot gather the data from all dogs and cats. Hence, the plan is to get a representative group of dogs and another representative group of cats. These representative groups were observed for some characteristics like the animal weight, amount of food in grams eaten per day, and breed of the animal. Included in the plan are factors like how many dogs and cats are included in the group, how to select those included in the representative groups, and when to observe these animals for their characteristics. Then after getting the data, or after we gather data, we must verify the quality of the data to make a good decision. Data quality check could be done as we process the data to summarize the information extracted from the data. Then, using this information, one can then make a decision or provide answers to the problem or questions at hand. Then to summarize, a statistical process in making a decision or providing solution to a problem include the following: planning or designing the collections of data to answer statistical questions in a way that maximizes information content and minimizes bias. Collecting the data as required in the plan. Verifying, of course, the quality of the data after they were collected. Summarizing the information extracted from the data. Then, examining the summary statistics so that insight and meaningful information can be produced to support decision-making or solutions to the questions or the problem at hand. Hence, several activities make up a statistical process, which for some, the process is simple, but for others, it might be a little bit complicated to implement. Also, not all questions or problems could be answered by a simple statistical process. There are indeed problems that need complex statistical process. However, one can be assured that logical decisions or solutions could be formulated using a statistical process. So what are the key points for this lesson? We differentiate between questions that could be and those that could not answer using statistics. Again, statistics is a science that studies data. And there are many uses of statistics, but its main use is in decision making. Logical decisions or solutions to a problem could be attained through a statistical process. Okay, so this will be our references. Okay, so now we will proceed to lesson 2, data collection activity. As we have learned in the previous lesson, again, statistics is a science that studies data. Hence, to teach statistics, real data set is recommended to use. In this lesson, we present an activity where you've done to provide some data that will be submitted for consolidations for the future lessons. Now, data on heights and weights, for instance, will be used for calculating body mass index. In the integrative lesson, no, students or you will also be given the perspective that the data you provided is part of a bigger group of data, as the same data will be asked from much larger groups. For example, the entire class, all grade 11 students in Holy Face, or all grade 11 students in the Rizal district. The contextualization of data will be also discussed later. Now, so what are the learning competencies for this lesson number 2? At the end of the lesson, the learner should be able to recognize the importance of providing correct information in the data collection activity. You will be able to understand the issue of confidentiality of information in data collection activity in compliance with our Data Privacy Act. Participate in the data collection activity. You may participate in the collection of some data and you may contextualize data. So, the lesson outline, preliminaries in data collection activity, performing a data collection activity, and contextualization of data. Okay. So, for example, no, you may prepare a sheet of paper and list your name with class student number, and the class student number is a random number chosen in the following fashion. So for example, okay, so since it's too hard for you to do that, I am the one who create your class student number. Then I make a box with the tickets or the small piece of papers of equal sizes, listing the number 1 up to number of students in our class. Now, I will shake the box, get a ticket, and assign the number in the ticket to the first person in the list. So, then I will shake the box again and get another ticket and assign the number of this ticket to the next person in the list. Now, until the end that we could get all the numbers listed in this class. Now, I just want again to reiterate that each student confidentiality is very important. Okay? Perhaps when the attendance is called, each student can be provided a separate piece of paper that lists his or name in class student number. We need to remember that the student number is always used this thorough with the semester whenever data are requested of them. The data collection activity, specific identifiers like their names are not required, especially because people have the right to confidentiality, but there should be a way to develop and maintain a database to check quality of data provided and verify from respondents in a data collection activity that data that they provided. Actually, these preliminary steps for generating a class student number and informing the confidentiality of the student number are essential for the data collection activities to be performed in this lesson and other lessons so that you can be uniquely identified without having to obtain your names. Of course, your student numbers are meant to identify you without having to know your specific identities in the class recording sheet. It helps protect confidentiality of information because it is not advisable for your classmate to know your grades, for example, in math or in English and so on. There is a confidentiality of information issues with it. In statistical activities, facts are collected from respondents or participants of the study for purposes of getting aggregate information. Again, but confidentiality should be protected. Okay, we need to know that the agency mandated to collect data is bound by law, especially the school, to protect the confidentiality of information provided by a respondent or by the students. So even market research organization in the private sector and individual researchers also guard confidentiality as they merely want to obtain aggregate data. In this way, participants of the study can be truthful in giving information, and the researcher can give a commitment to participants of the study that the data they provide will never be released to anyone in a form that will identify them without their consent. Okay, so we have a performing a data collection activity. So for example, it is important that in research, they provide the needed information to the best of their knowledge. Also, before they respond to the questionnaire provided in attachment as a student information sheet, it is recommended that each item in the SIS should be clarified. The following are the suggested clarification to make for each item. So, for example, for class student number, this is the number that you provided confidentiality to the student at the start of the class. Okay? Sex. This is the student biological sex and not their preferred gender. Hence, you have to choose only one of the two choices by placing a mark or check mark at the space provided before the choices. Okay? Number of siblings. This is the number of brothers and sisters that the student has in their nuclear or immediate family. This number excludes him or her in the count. Thus, if the student is the only child in the family, then she will report 0 as his or her number of siblings. For the weight, This refers to the student weight based on the student knowledge. Note that the weight has to be reported in kilograms. In case the student know his or her weight in pounds, the value should be converted to kilogram by dividing the weight in pounds by a conversion factor of 2.2 pounds per kilogram. And for the height, it must be in centimeters, of course. This refers to the student height based on the student's knowledge. Note that the height has to be reported in centimeters. In case the student knows his or her height in inches, the value should be converted to centimeters by multiplying the height in inches by a conversion factor of 2.54 centimeter per inch. Age of mother. As of her last birthday in years. This refers to the age of the student mothers in years as of her last birthday. Thus, this number should be reported in whole number. In case the student mother is dead or nowhere to be found, ask the student to provide the age as if the mother is alive or around. You could help the student in determining his or her mother's age based on other information that the student could provide, like birth year of the mother or student's age. We note also that a zero value is not an acceptable value. Usual daily allowance in school. This refers to the usual amount in pesos that the student or you is provided for when or he or she goes to school in a weekday. We need to take note that you can give zero as response for this item in case you has no monetary allowance per day. Number 8, usual daily food expenditure in school. It must be in pesos, of course. This refers to the usual amount in peso that you spend for food including drinks in school per day. We need to take note that you can give zero as response for this item and he or you does not spend for food in school. Usual number of text messages sent in a day. This refers to the usual number of text messages that you send in a day. We need to take note that you can give zero as response for this item in case you does not have the gadget to use to send a text message or simply you does not send text messages. Most preferred color. The U is to choose a color that could be considered you most preferred among the given choices. We need to take note that you could only choose one. Hence, you have to place a check mark at space provided before the color you consider as your most preferred color among those given. Usual sleeping time. This refers to the usual sleeping time at night during a typical weekday or school day. We need to take note that the time is to be reported using the military way of reporting the time or the 24-hour clock. Happiness index for the day. You have to respond on how you feel at the time using codes from 1 to 10. Code 1 refers to the feeling that the student is very unhappy, while code 10 refers to a feeling that you is very happy on the day when the data are being collected. So after that, you are provided at most 10 minutes to respond to the questionnaire. Okay? So you just answer all those questions. You must write it to your yellow paper or in a coupon band. Okay. So, you are required to submit the completed SIS so that I could consolidate the data gathered using a formatted worksheet file provided to you later. So, having the data in electronic file makes it easier for us to use it in a future lesson. So, be sure that you provided the information in all items in the student information system. So, you are I will going to compile all your responses, and compiling all these records from everyone in the class is an example of a census, since data has been gathered from each and every student in our class. We need to take note that the government, through the Philippine Statistics Authority, conducts censuses to obtain information about socio-demographic characteristics of the residents of the country. Census data are used by the government to make plans, such as how many schools and hospitals to build, and censuses of population and housing are conducted every 10 years on years ending in 0. Example, 1990, 2000, 2010, to obtain population counts and demographic information about all Filipinos. In the mid-decade, population censuses have also been conducted since 1995. Censuses of agriculture and Philippine business and industry are also conducted by the Philippine Statistics Authority to obtain information on production and other relevant economic information. Again, the PSA is the government agency mandated to conduct censuses and surveys. Through Republic Act 10625, also referred to as Philippine Statistical Act of 2013, the Philippine Statistics Authority was created from four former government statistical agencies, namely National Statistics Office, National Statistical Coordination Board, Bureau of Labor and Employment of Statistics, and Bureau of Agriculture Statistics. The other agency created through RA 10625 is the Philippine Statistics Research or Statistical Research and Training Institute, which is mandated as the research and training arm of the Philippine Statistical System. Take note that the Philippine Statistical Research and Training Institute was created from its forerunner, the former Statistical Research and Training Center. So, we may proceed to contextualization of data. Okay, students, what comes to your minds when you hear the term data, which may be viewed as a collection of facts from experiments, observations, sample surveys and censuses, and administrative reporting system? So, example, this will be the following collection of numbers, figures, symbols, and words, and try to consider the collection as data. So we have 3, red, F, 156, 4, and so on and so forth. Although the collection is composed of numbers and symbols that could be classified as numeric or non-numeric, the collection has no meaning or it is not contextualized, hence it cannot be referred to as data. Because the data are facts in figures that are presented, collected, and analyzed. Data are either numeric or non-numeric and must be contextualized. To contextualize data, we must identify its 6 W's, or to put meaning on the data, we must know the following W's of the data. Okay, so data are facts in figures that are represented, collected, and analyzed. Data are either numeric or non-numeric and must be contextualized. The contextualized data, we must identify its 6 W's or to put meaning on the data. And we must know the following W's of the data. Number 1, who? It means to say that who provided the data. What? What are the information from the respondent, and what is the unit of measurement used for each of the information, if there are any. When was the data collected? Where was the data collected? Why was the data collected? And 6, how was the data collected? Let us take as illustration the data that you have just collected, that I just collected a while ago, and let us put meaning or contextualize it by responding to the questions with the W's. it is recommended that your answer the W question so that you will learn how to do it. So, for example, question number 1, who provided the data? So, of course, the answer is the student in the class provided the data. For number 2, what are the information from the respondents or from the students? And what is the unit of measurement? The answer is, the information gathered include class student number, sex, number of siblings, weight, height, age of mother, usual daily allowance in school, usual daily food expenditure in school, usual number of text messages sent in a day, most preferred color, usual sleeping time, and happiness index for the day. Then the unit of measurement for the information of the number of siblings, weight, height, age of mother, usual daily allowance in school, usual daily food expenditure in school, and usual number of text messages sent in a day are person, kilogram, centimeter, year, pesos, and message respectively. For number 3, when was the data collected? Of course, the answer, the data was collected on the first few days of classes for statistics and probability. For number 4, where was the data collected? The data was collected through online. Either Google Sheet or by sending into FB message or private message. Number 5 was, or why was the data collected? So, of course, as I mentioned earlier, the data will be used in our future lessons in statistics and probabilities. How was the data collected? So, you provided the data by responding to the student information sheet prepared and distributed by yours truly for the data collection activity. So, once the data are contextualized, there is now meaning to the collection of numbers and symbols which may now look like the following, which is just a small part of the data collected in the earlier activity. So, for example, class number student is 1, gender is M, number of siblings 2, and so on and so forth. So, what are the key points of this lesson? Providing correct information in a government data collection activity is a responsibility of every citizen in the country. So, the data confidentiality is important in a data collection activity. Census is collecting data from all possible respondents. Data to be collected must be clarified before the actual data collection. In data must be contextualized by answering 6 W questions. Okay, and this will be our references for lesson number 2. Okay, lesson number 3, basic terms in statistics. At the end of the lesson, the learner is able to define universe and differentiate it with population, and define and differentiate between qualitative and quantitative variables, and between discrete and continuous variables that are quantitative. We need to recall the previous lesson on contextualizing data, definition of basic terms, statistics, universe, variable, population, and sample, and the broad of classification of variables, qualitative and quantitative, discrete and continuous. Okay, so as what we do a while ago, that we get the data provided by our previous lesson and on how we'll be able to contextualize the data. Now you could see the compiled data set in a table presented in our presentation. Of course, the response on the first double use of the data, that is on the questions who provided the data. And of course, last time, you are the class you are the one who provide the data, or the data were taken from you. Another double use of the data is what? So what are the information from the respondents? And we give it already last time. So as what I have here, so we have a subgroup of universe or a population. But prior to that, the collection of respondents, no, from whom one obtained the data is called the universe of the study. Again, the collection of respondents from whom one obtained the data is called the universe of the study. The set of students of this statistics and probability class is our universe. But we must precaution that a universe is not necessarily composed of people, since there are studies where the observation were taken from plants or animals, or even from non-living things like buildings, vehicles, farms, and others. So normally, we define universe as a collection or a set of units or entities from whom we got the data. Thus, this set of units answer the first double use of data contextualization. On the other hand, the information we ask from the students are referred to as the variables of the study and in the data collection activity. We have 12 variables, including class student number. Then a variable is a characteristic that is observable or measurable in every unit of the universe. So from the student of the class, we got your age, number of siblings, weight, height, and so on and so forth. Then, since these characteristics are observable in each and every student of the class, then these are referred to as variables. Okay? The set of all possible values of a variable is referred to as a population. Again, the set of all possible values are a variable is referred to as a population. Thus, for each variable we observe, we have a population of values. The number of population in a study will be equal to the number of variables observed. So in the data collection activity we had, there are 12 population corresponding to 12 variables. Now, a subgroup of a universe or a population is a sample. So there are several ways to take a sample from a universe. So, or a population, and the way we draw the sample dictates the kind of analysis we do with our data. So we can further visualize these terms with this figure. Okay, so and now we can further visualize these terms in the following figure. So as what we have here, we have variable 1, variable 2, and variable 12. So the first one is the universe, the population of variable 1, variable 2, and variable up to 12. Then a sample of units or a sample and a sample of populations. The broad classification of variables. Following up with the concept of variable, so a variable takes on several values, but occasionally a variable can only assume on one value. Then it is called a constant. So for instance, in a class of 15 years old, the age in years of student is constant. So take note, variables can be broadly classified as either quantitative or qualitative, with the later further classified into discrete and continuous types. Okay, now, qualitative variables express a categorical attribute. Okay, while quantitative, of course, data whose sizes are meaningful answered questions such as how much or how many. So as what we have here, qualitative variables express a categorical attribute. such as sex, male or female, religion, marital status, region of residence, highest educational attainment. Qualitative variables do not strictly take on numeric values, although we can have numeric codes for them. For example, for sex variable 1 and 2 may refer to male and female respectively. Qualitative data answer questions what kind, and sometimes there is a sense of ordering in qualitative data. So income data group into high, middle, and low income status. Data on sex or religion do not have the sense of ordering, as there is no such thing as a weaker or stronger sex, and a better or worse religion. Qualitative variables are sometimes referred to as a categorical variable. When it comes to quantitative, otherwise called numerical, data whose sizes are meaningful answered questions such as how much or how many. Quantitative variables have actual units of measure. So example of quantitative variables include the height, weight, number of registered cars, household size, and total household expenditure. Income of survey respondents. Quantitative data may be further classified also into discrete or continuous. Now, when you say discrete, data are those data that can be counted, while continuous data are those that can be measured. So, as what we have here, with this classification, we need to understand that that the variable in our last data gathering activity, it should be to classify this variable as to qualitative or quantitative, and furthermore as to discrete or continuous. So as what we have here. So class student number, that is qualitative. For sex, that is qualitative. For weight, continuous at the same time, quantitative and continuous, and so on. So what are the key points? Of course, again, a universe definition, a variable, a population, a sample. In a study, there is only one universe but could have several population. And variables could be classified as qualitative or quantitative. And the latter could be further classified as discrete or continuous. It is very important to us always to cite the references. And this will be the references for lesson number 3. Now, for lesson 4, we have levels of measurement. Okay? So in this lesson, we discuss the different level of measurement as we continue to explore data. Knowing such will enable us to plan the data collection process, and we need to employ in order to gather the appropriate data for analysis. So at the end of the lesson, you as a learner be able to identify and differentiate the different level of measurement and methods of data collection. Okay, so we have here the activity. So, plan or design the collection of data to verify verify the validity of the statement in a way that maximize information content and, of course, maximize information content and minimize bias. So, collect the data as required in the plan, verify the quality of data after it was collected, and summarize the information extracted from the data. And we need to examine the summarized statistics so that the insight and meaningful information can be produced to support your decision whether to believe or not to be given. So we have what we call the levels of measurement. So there are four levels of measurement of variables. We have nominal, ordinal, interval, and ratio. So as what we have here, we have a level, then property in the basic empirical operations. So we have the definition of nominal, ordinal, interval, and ratio. Now, we need to take note that the level of measurement depends mainly on the method of measurement, not on the property measured. So the weight of primary school students measured in kilograms has a ratio level, but the students can be categorized into overweight, normal, underweight, and in which case the weight is then measured in an ordinal level. So as what we have here, we have the class student number, the variable, and of course the level of measurement. And of course, to assess the understanding, you may go back to the set of variables in the data gathering activity that we done in lesson 2. So, as what you have here, based on what I've mentioned, we have the variable. So, you are now very familiar with the example of variable. And we need to identify their level of measurement, as what we have here. So, the method of data collections. Okay? So, variables were observed or measured using any of the three methods of data collection. So, of course, namely, objective, subjective, and use of existing records. The objective and subjective methods obtain the data directly from the source. The former uses any or combinations of the five senses, sense of sight, touch, hearing, taste, and smell, to measure the variable, while the latter obtains data by getting responses through a questionnaire. The resulting data from these two methods of data collection is referred to as primary data. So the data gathering in our lesson 2 are primarily data and were obtained using the subjective method. On the other hand, secondary data are obtained through the use of existing records or data collected by other entities for certain purposes. So for example, when we use data gathered from the PSA, we are using secondary data, and the method we deploy to get the data is the use of existing records. Other data sources include administrative records, news articles, internet, and the like. However, we must emphasize to every student that when we use existing data, we must be confident of the quality of the data we are using by knowing how the data were gathered. Also, we must remember to request permission and acknowledge the sources of the data when using data gathered by other agency or people. So, what are the key points for this chapter? We discussed the four level of measurement, the nominal, ordinal, interval, and ratio. You are now knowledgeable on what level the variable was measured or observed will guide us to know the type of analysis to apply. We discussed the three methods of data collections include objective, subjective, and use of existing records. And using the data collection method as basis, data can be classified as either primary or secondary data. Okay, so this will be our references. Albert J.R.G., The Basic Statistics for Tertiary Level, Handbooks of Statistics from UP Los Baños, Takashi, and Workbooks in Statistics. Lesson number 5. In this lesson, we enrich what you have already learned from grade 1 to 10 about presenting data. Additional concept could help you to appropriately describe further the data set. So, we have the learning competencies and the lesson outline. So, we have what we call textual or narrative presentation. Actually, you may list on the different responses, no? So, you could summarize, we could summarize the responses to establish what we already know about the data presentation techniques, and we could build other concepts on the topic. So, we classify your answers according to the three methods of data presentation. So, textual, tabular, and graphical. A possible listing will be something like this. So, textual or narrative presentation, detailed information are given in the textual presentation, while narrative report is a way to present the data. Okay? Now, for tabular presentation, numerical values are presented using tables. Information are lost in tabular presentation of data. Then frequency distribution table is also applicable for qualitative variables. Then for graphical presentation, trends are easily, of course, in graphs compared tables. Information are lost in tabular, of course, presentation of data. It is good to present data using pictures or figures like the photographs. Pie charts are used to present data as part of a one whole. Line graphs are for time series data. And it is better to present data using graphs than tables as they are much better to look at. Now, of course, in general, there are three methods to present data. Two of all of these three methods could be used at the same time to present appropriately the information from the dataset. These methods include textual, narrative, tabular, and graphical methods of presentation. In presenting data in textual or paragraph or narrative form, one describes the data by enumerating some of the highlights of the dataset, like giving the highest, lowest, or the average values. In case there are only few observations, say less than 10 observations, the values can be enumerated if there is a need to do so. So, we have an example actually, no? Data could also be summarized or presented using tables. Okay? So, the tabular form or the tabular method of presentation is applicable for large data set. Trends could easily be given in the kind of presentation. However, there is a loss of information when using such kind of presentation. The frequency distribution table is the usual tabular form of presenting the distribution of the data, and the following are the common parts of the statistical table. So we have the table, column, row, and body. So this will be a regional estimate of poverty incidence among families based on the family income and expenditure survey conducted on the same year of reporting. The graphical presentation, on the other hand, is a visual presentation of the data. Graphs are commonly used in an oral presentation. There are several forms of graphs to use, like the pie chart, pictograph, bar graph, line graph, histogram, and box plot. Which form to use depends on what information is to be relayed. So, for example, trends across time are easily seen using the line graph. However, values of variables in nominal and ordinal levels of measurement should not be presented using a line graph. Rather, a bar graph is more appropriate to use because a graphical information in the form of vertical bar graph of 2012, no, regional estimates of poverty incidence among families, no, as what we have here. No? So, this will be the graphical representation in the form of vertical bar graph of 2012. And of course, the other example or graphical presentation that are shown below are the lifted from the Handbook of Statistics. Okay? This will be the weapons arrest rate from 1965 to 1992 by age of offender. Then the figure 5.5 height and weight of Stat 1 students registered during the previous term. Now, the frequency distribution table in histogram. A special type of tabular and graphical presentation is the frequency distribution table or FDT in its corresponding histogram. So we have the steps in construction of a group FDT. So we have to identify the largest data value on the maximum and the smallest data value or a minimum from the data sets of compute the range. The range is the difference between the largest and the smallest value. So it means to say that range is equal to max minus or deducted to minimum. Then determine the number of classes. So we have an instruction here on how we'll be able to construct the group of FDT up to the tally of data into the classes constructed. And of course, the histogram is a graphical representation of the frequency distribution table in the form of a vertical bar graph. So the key points, of course, three methods of data presentation. Two are or all of the methods could be combined. Then distribution of data is presented using frequency distribution table and histogram. And that this will be our references for lesson number 5. For lesson number 6, measure of central tendency. Okay? So, of course, we have the overview of the lesson, we have the learning competencies, and the lesson outline. So, we have here the frequency distribution table of the monthly income of 35 families residing in a nearby barangay or village. So, you can pick up your interest and at the same time, you may introduce the summary of statistics. So, what are the common? Of course, measure of central tendency. We have mean, median, and mode. So, we could compute the mean, usually denoted by Greek letter. Of course, the mean with this formula. Okay, and then alternatively, we could do the computation as follows. While the median, of course, no? On the other hand is the middle value in the array of observation. So to determine the median of the data set, the observation must first be arranged in an increasing or decreasing order. Then locate the middle value so that half of the observation are less than or equal to that value while the half of the observation are greater than the middle value. For the properties of the mean, median, and mode, of course, as mentioned before, the mean is the most commonly used measure of central tendency since it could be linked or likened to the center of gravity, and since the variable is an array were to be put on a beam balance, the mean acts of the balancing point where smaller observation will balance the larger ones as seen in the following illustrations as what we have here. Then, of course, the sum of the difference across all observation will be equal to 0. So, this indicates that the mean indeed is the center of the distribution since the negative and positive deviation cancelled out and the sum is equal to 0. So, the following diagram provides a guide in choosing the most appropriate measure of central tendency to use in order to pinpoint or locate the center of the middle of the distribution of the data sets. So what are the key points? Of course. Okay, so we must observe that we are always give credits to our references. So this will be the references for module number 6. Then in lesson 7, we have the overview, learning, and lesson outline. Now, so in the previous lesson, actually, no, we had a identified the highest and lowest family income and emphasized that the highest and the lowest values, which are commonly known as maximum and minimum respectively, are important summary measures of a data set. They represent important location values in the distribution of the data. However, these measures do not give a measure of location in the center of distribution. Instead, these two location measures give extreme local or location or points in distribution. So, the following distribution of scores in a 50-item long test of 150 grade 11 students of a nearby senior high school and of course this will be a score in a long test and a number of students. So what is the highest score and the lowest score? So as what we have here, the highest score is 50 while the lowest is 10. What is the most frequent score or most commonly score? We have 38, which is the score of 28 students. Then, what is the median score? So, the median score is 33, which implies that 50% of the students, or around 75 students, have score at most 33. What is the average of the mean score? On the average, the student got 32.0.4667 or 32 rounded up out of 50 items correctly. Then we formally define the maximum and measure of location that pinpoints the highest value in the data distribution while the minimum locates the lowest value. So this will be the key points for that discussion. Of course, we need to appreciate and to thank and acknowledge our references for this module. Then we may proceed to lesson 8. So we have again the overview of the lesson, the learning competencies, and the lesson outline. In particular, no, summary measure of variability such as the range and the standard deviation of the rate of return are used to measure risk associated with investment. We could use measures of variation to decide whether it would make any difference and if we decide to invest wholly in stock A, wholly in stock B, or half of our investment. No, thus we choose investment where the risk of the rate of return has a small measure of dispersion. There are two types of measures of variability or dispersion. Okay, so of course, one type is the absolute measure, which include the range, interquartile, range, variance, and standard deviation. The absolute measure of dispersion provides a measure of variability of observation or values within a data set. On the other hand, the relative measure of dispersion, which is the other type of measure of dispersion, is used to compare variability of data sets of different variables or variable measures in different units of measurement. The coefficient of variation is a relative measure of variability. Now, the absolute measure of dispersion. Okay? The range is a simple measure of variation defined as the difference between the maximum and minimum values. The range depends on the extremes. It ignores information about what goes in between the smallest and the largest values in the dataset. The larger the range, the larger is the dispersion of the dataset. And we already encountered the range in previous lesson where we discussed the construction of an FDT. We have also, before that, we have also the interquartile range, no, or IQR. It is the difference of the third in the first quartile. Okay? We have also what we call a variance, no, which is denoted as squared. And the variance is a measure of dispersion that accounts for the average squared deviation of each observation from the mean. And since we square the difference of each observation from the mean, the unit of measurement of the variance is the square of the unit used in measuring each observation. Such property is a little bit problematic in interpretation. So for example, point squared or kilogram squared is difficult to interpret compared to inches squared. Hence, instead of the variance, the standard deviation is computed, which is in the positive square of the variance. The relative measurement of dispersion or coefficient of variance. To compare variability between or among different data sets, that is, the data sets are different variables or same variables but measured in different unit of measurement. And that is what we call coefficient of variables. It is used as measure of relative dispersion. Okay? So the key points of course is listed here. Okay, this slide shows the list of our references. For lesson number 9, more on describing data summary measures in graphs. So, of course, we have what we call body mass index or the BMI. This will also make you more confident to discuss BMI in the, of course, to integrate the lesson we learned in our last chapter. Now, BMI divided by the Odolphe-Quetelet, it is defined as the body mass divided by the square of the body height, and it is universally expressed in units of kilogram, using weight in kilograms and height in meters. When the term BMI is used informally, the units are usually omitted. A high BMI can be an indicator of high body fatness. The BMI can be used to screen for weight categories that may lead to health problems. And of course, the BMI provides a simple numeric measure of a person's thickness or thinness, allowing medical and health professionals to discuss weight problems more objectively with the adult patients. The standard weight status categories associated with BMI range for adults. So, as shown here in our figure, we have the BMI range, weight status, and the health risk. So, below 18.5 BMI, underweight. 18.5 to 22.9, normal or healthy weight. 23 to 27.4, overweight. 27.5 and above, obese. Okay? Okay, so this will be the summary statistics of the variable height in meters using the sample data. So as what we have here, we have the measure of location, minimum, maximum, mean, first quartile, median, third quartile. So the measure of dispersion, we have range, IQR, and standard deviation. So using the data of the scores of 150 grade 11 of the nearby senior high school for the 50 long test, so we could demonstrate the computation of this measure by getting the cumulative frequency. Of course, so this will be an example of square the difference to measure the spread of observations. Okay, this will be for the coefficient of variation. And this will be the key points for that lesson. Okay, so we would like to acknowledge our references. this will be the list of our references for this lesson. So summary, measure in graphs. So we have the BMI as what we discussed, the percentage, and of course, the student height and weight in corresponding BMI. So now you could test, for example, so what will be your gender or sex, of course, your height in meters, then weight in kilograms for you to find out your BMI, rounded up to the whole number. So this will be the summary as I mentioned. Then you may get your interquartile range or IQR. Then this will be the statistics of the variable weight in kilograms using the sample data as we presented earlier. This will be the variable BMI in kilogram using the sample data, again by descriptive measure and the computed value. Using the sample class data, so the following figures provide the box plots for the variable heights. So construction of box plot. And this will be the box plots of the variable BMI for the 30 students by gender or by sex. Then this will be the key points for lesson number 9. And of course, before we end, I would like to acknowledge our references. So listed here again is Albert, Armspans, deciding which measure of center, of course, from sharemylesson.com, Handbook of Statistics 1, from the Faculty Institute of Statistics at UP Los Baños, College Laguna, and Workbooks in Statistics 1, authored by the Faculty of the Institute of Statistics, UP Los Baños, College of Laguna. 1st to 13 editions. Thank you very much. Okay, thank you very much and good luck. Godspeed. I will post, of course, a video on how we'll be able to compute the mean, the median, the quartile, the standard deviation, and others. So, wait for my video uploaded to my YouTube account. So, good luck everyone and enjoy learning.